Good day, my dear students. Welcome back to my channel, Otababa Music TV. And for today's video tutorial, I am going to teach you how to transform quadratic function defined by y equals ax squared plus bx plus c into the form y equals a times quantity x minus h squared plus k. But before we proceed, if you are new to my channel, please don't forget to subscribe and hit the notification bell so that you will be updated for my next videos. The most essential learning competencies for this module 11, is the learner transforms the quadratic function defined by f of x equals ax squared plus bx plus c into the form f of x equals a times quantity x minus h squared plus k. So you are expected to transform the standard form of quadratic function into the vertex form. But before we discuss this module, I am going to show you how the vertex form is derived from standard form. So how was the vertex form of quadratic function is derived from the standard form of quadratic function? So the standard form of quadratic function, it is f of x equals ax squared plus bx plus c, and the vertex form equals a times quantity x minus h squared plus k. Okay, before we proceed to derivation of the vertex form from the standard form of quadratic function, let us remember first the special product. One of the special product is the square of binomial. You can still remember the square of binomial is in this form. X plus, say for example, 1 quantity squared. So this is square of binomial. The square of binomial is a perfect square trinomial. When we expand this will become x plus 1 times x plus 1. So to find the product, we will use the FOIL method. So in FOIL method, we multiply the first term. So this is the first term. So x times x is x squared. And then outer term, the x times 1. This is our outer term. So x times 1 equals x. And then inner term, the inner term is 1 times x. So still x. And then the last term is 1. So this is 1. 1 times 1 is 1. Then after that, we combine like terms. So we have here, so copy x squared plus, so x plus x equals 2x. then plus 1. So this is now the square of the binomial x plus 1. Okay. Now, so let us take note of the pattern that we can get here. The middle term, if you notice the middle term, this one is twice of the last term and the first term here. So we have 1 here. So meaning 1 times 1 equals 1 times 2. So that is our middle term. So in short, when we find the square of binomial, we will just, for example, x squared plus 2, x squared plus 2, so x plus 2 quantity squared. Now, how do we find directly the square of this binomial? And the square of this binomial is a perfect square trinomial. So we square the first term. So x square, and then plus, if it is positive, twice the product of the first and the last term. So twice meaning times 2. So x times 2 is 2x times 2 becomes 4x, and then square the last term, square the last term, so you have 4. So this is now the square of the binomial x plus 2. So x squared plus 4x plus 4. So if you are going to show it in this manner, it will still give the same answer. This is x plus 2 times x plus 2. Okay, so I hope you understand it. Okay, now what if the quadratic expression is not a perfect square trinomial? Okay, now if we do it in here, we apply here, so this one is not a perfect square trinomial. So we will rewrite the function into y equals ex squared plus bx plus c. Okay, so this is not a perfect square trinomial because c is not a perfect square number. So what we're going to do, we're going to apply addition property of equality, and then so that we can eliminate c here. Okay, so what we're going to do here, we're going to apply addition property of equality so that we can eliminate c at the right side of our equation. So this will become y minus c equals ax squared plus bx plus c minus c. So we can cancel now c here, so becomes 0, and what is left now is y minus c equals ax squared plus bx or plus bn. We are going to factor out a here, so we will factor out a so that we can get rid of the leading coefficient. Our purpose here is we're going to make the leading coefficient, the coefficient of the quadratic terms, become 1. So we will factor out a. So when we factor out a, so we divide by a here. So divide by a comes y minus c equals a times, so cancel ang a, becomes x squared plus b over a x. Okay, so next is we're going to complete the square. We will complete the square so that we can obtain a perfect square trinomial. So we also apply addition property of equality when we complete the square. So we will add so whatever value we add to the right side of the equation, that is also the value that we're going to add at the left side of the equation. So we will leave a room here for whatever value that we're going to add at the right side of the equation. Okay, so that's it. Now, in our example, the middle term, we obtain it by multiplying the first term and the last term and multiply it by 2. So the first term and the last term, we multiply it by 2. That is the middle term. So meaning, to get the last term, for example here, in 4. So how to get 4 here? So 4 is, we multiply the first term 1 times 2 is 2. So twice that is 2 times 2 is 4. That is our middle term. Now to get the last term, since the last term is this one, is the square. So what we are going to do, we are going to last term divide the middle term, becomes divide by 2, and then we square that. So we square, so this one. So divide by 2 and then square of that. So that to get the last term again, to get the last term, you square, you divide the middle term by 2 and then you square it. So this will become 4 divided by 2 is 2. So 2 squared equals 4. So this is our last term or the third term. So we will do it also here. So our middle term is b. So this will become b over a, and then we divide by 2 and then square it. That is to get the last term. So but before we square that, we are going to evaluate the inner part. So this will become now b over 2a times 1/2. So that is will be divide fraction quantity. So this will become b squared over square of 2 is 4, so 4a squared. Okay, I hope it's clear. Or you can do it in this manner if you want to square directly. This will become, this can be solved also in this manner, b squared, because you distribute 2, then 2 also here, over a squared, and then 2 here becomes 2 squared is 4, and then this will become b squared over a squared times 1/4, the reciprocal of the divisor. So same answer. Okay, so our third term is now b squared over 4a squared. So this is b squared over 4a squared. So this is now a perfect square binomial, and this can be expressed now as square of binomial. So we also add b squared over 4a squared here. So b squared over 4a squared. Okay. So I hope it is clear. Okay. Then in this part we can cancel a. So to simplify, we simplify further. So this will become now y minus c plus b squared over 4a equals, and then we will express this as square of binomial. So a times x plus b over the square root of b squared is b, the square root of 4 is 2, the square root of x squared is x, the square root of a squared is also a, 150. So this is now the square of binomial. Then we're going to, on this part, we're going to cross multiply. We combine, so it becomes 4ac plus b squared. So cross multiply here, and then there is 1 here, then we multiply, so 1 times b squared is b squared, then c times 4a is, and then multiply the denominators, 4a squared, 4a rather, equals, just copy, a times x plus b over 2a quantity squared. Express this as function. This will become now y equals a times quantity. We apply addition property of equality here, and we will write it directly as a times quantity x plus b over 2a squared plus, since this is negative, so plus 4a, and since this is positive becomes negative, minus b squared over 4a. So this is the quadratic function. Now, since this is what we call vertex form quadratic function, we identify the coordinates, so the x coordinates and the y coordinates. So our y coordinates is here in this part. So here is our y coordinate, and on this part is our x coordinate. So we will solve for y coordinate. So our y equals 4ac minus b squared over 4a. By doing it as encircle, this is the box. So this is the resulting quadratic function that we have derived from our derivation. Okay, now for your x is in this part, it will become, so x, since this is positive, becomes negative, so equals negative b over 2a. So this is now your, this is your y coordinates, the value, your y coordinates, and the value of your x coordinate. Now we let x equals h, okay, and y is our, so we are going now to simplify. To write in simplest form, we will substitute the value of x here and the value of y here. So this will become now as a function of x, so f of x equals, so x, so our x is h, since the value of x is negative, so So that is now negative h here. Quantity squared plus, so our y is k, this one here, plus k. Okay, so this is now the vertex form of quadratic function, wherein h is the x coordinate and y and k is the y coordinate, written as an ordered pair of h, k. Okay, so I hope you have followed the procedure in deriving the standard form of quadratic function to the vertex form of quadratic function. So this is your teacher, Sir Ababa, saying, in every problem in math, there is always a solution. Don't forget to subscribe and hit the notification bell so that you will be updated for my next video. Thank you so much for watching. Have a nice day and God bless everyone.